All right, so today we are going to talk about what is a relational database, right? So earlier you learned a database is a place where we can store our data in a systematical way. And there are two methods, or like two ways of storing the data, which we call manual and electronical. And you learn there are many benefits when we are storing data electronically. Those are the facts that we have learned very finely at the last session. So we compare the manual database with the electronic database, and I think you know now there is a huge benefit by storing the data in an electronical way, right? So today we are going to talk about what is a relational database. Right, so now databases can be there, right? They can store the data, but there can be relational database and non-relational database as well. Like if you just take a manual book, it is not, in most of the cases, it is not going to be a relational database. If we are going to use the term which is relational, it indicates the data which is inside that database are in a way which is related to each other, right? Now, these are the objects, or these are the things that we are going to talk inside regarding a relational database. A collection of fields related to one person or object is called a record. So in very simple terms, if you take this particular table, the first table that you can see, there are two records. This is one record and this is another record. So when we have some details or some related information regarding one particular object, we call it a record. And collection of records will create a data table, right? So without the records, the table structure can be there, but it's not going to be a data table, right? So if it is a data table, a collection of records will be there, right? And these, like this, we can create many different tables for many different objects, right? So as an example, if you want to, if you think about a school, if you want to store the details of the students, we can maintain a particular table which has the index number, the student name, the addresses, the contact numbers, and all these things, all the details related to a student. As well as we can maintain a table to keep or to record the details of the teachers. So teacher ID will be there, teacher's NIC will be there, teacher's name, date of birth, the subjects that she's teaching, and all these things will be there, right? So likewise, regarding a particular situation or particular scenario, there will be many different data tables which contains many different data. Now, if you think about the example that I told you, like we have the details of the students, we have the details of the teachers. So in case if we need to find a particular student, let's say the student, the student called Saman. If I need to find who is the class teacher of the Saman's class from the database or from the data tables that we have, like having the tables record the details regarding the student and teacher alone will not give us any clue to find which teacher is the class teacher of the Saman's class, right? So for that, to find that, we need to have some relation in between these tables. Now, if you take the very third line, the last line of the explanation, it says a collection of related table is called a relational database. Now, see how the how it flows. So first it says collection of fields related to one person or object is called a record. So as I told you, these are the collection of fields, the different kinds of fields. Student number is one kind of a field. The name is one kind of a field. Date of birth is another kind of a field. So collection of those fields create a record, and collection of those records create this table. And finally it says collection of these tables will create a database. So when these tables are related, or like when they are connected, when we can find a connection in between these tables, we call that collection of tables is a relational database, right? So that's how the relational database comes to play. Like if the table does not have the relation or does not have the connection in between, we cannot say it is as a, we cannot identify or we cannot call it is a relational database. It can be called just a database, but not related, right? So if we need to call a particular database a relational database, the tables which inside that database should have a connection, right? Now, if I take this example, you got student number, name, date of birth, date of admission in here. So it's kind of student details that you got. And here, student number, book number, borrowed date, return date, it's kind of a details where a particular student, the books those are being borrowed by a particular student. So if I want to find which kind of books are being borrowed by which one of these students, I need to have a relation in between, right? So if I just had only this table without a relation, so I won't be able to find which one borrowed which book. Right now, if you want to find who has borrowed the book number 2222, so it's easy for you to find, right? Because it says 2222 is borrowed by the student number 101. So that student number 101 belongs to the Firoza Rafiq. So you can clearly say this particular book has been borrowed by this particular student. Now, in between these two tables, then who is creating the relation? It's the student number. Using the student number, these two tables are being related to each other. Now, if you think a table, or like if you create the table without this student number in this table, if you create this table without this student number, then you won't be able to find who has been borrowed the book number 2222 because you don't have the corresponding reference, right? Okay, people, is that clear how a relational database works and why we call a particular database a relational database? Yes, everyone, is that clear? Okay, great.
Yes, sir.
Right, okay. So then it shows us the relation, how the particular table is formed, how a particular record is formed, and how finally a particular relational database is formed. We have discussed about this, right? Okay, then they have given some examples over here, right? So these are some of the details which is collected using the biodata forms, right? Which is not a very organized data, right? We have some data, but it is not that organized. And if you think about these biodata forms, you have admission number in each record, actually in each database biodata form. You got a name, you got a date of birth in everywhere, you got a gender, and you got telephone number, right? So by referring to these, now this is not a proper table. By referring to this, we can create a proper table. We can propose some field names and we can store the details with reference to these forms. Right now, it is the general way of forming a table. First, we gather the data using a particular form. So referring to those forms, we create a table, right? So in this table, you can see you got proper field names, say an admission number, name, date of birth, gender, student phone number. And under that, in one particular record indicates the details regarding one particular student, right? If you take the first record, it's 1426, Kamindu Papasara's record is there. Second is, it is Meena Devi, Ram Nathan, right? Yes, data is there, right? So Muhammad Malikar data is there as the third one, right? So it is being properly organized when it comes to a table, right? Okay, so here they have shown you the things which we already know. A particular row is called a record. A particular column is called a field, right? Which we know already. So unlike a normal table, like both the table, like all the tables which is inside a database and which are not inside a database, like the general tables, has these columns and rows, right? So every table generally have columns and rows. But when a table plays inside a database, column is given a special name called field, and the row is given a special name called records, right? So that's the database jargon, right? Column is called a field, row is called a record, right? Okay, so now if you take the table 9.6, these two tables that you can see on the screen, how many records are there in the first table? The first table like records how many are there? Yes, that's good. That's right. Udamya. Yes, others, how many records are there in the first table? Yes, great. And how many fields are there in the first table? How many fields? Yes, Osanda, that's right. That's right. Yes, yes, very good, people. So there are 2 records and 5 fields are there, right? Now, this is what I was talking about. When the relations are there, you can find the specific details that you want. Now here they have given another example which indicates the table which contains the student details, and the table which contains the borrowings, and the table which contains the book details, right? Now, if I want to find who has borrowed, example, who has borrowed the basic maths concept book, what is going to be my answer? Who has borrowed the basic math concept book? What's the name of the person who has borrowed the basic math concept? Yes. Yeah, it's Firoza, right? So it's easy to find. Nether basic math concept. The book number is 111. So from this table, I can find who has borrowed 111. It is 101. So 101 is Firoza Rafiq, right? Now, this is what we call relational database. So all the tables are related. It's not related to each and every other thing, but somehow they are related, right? It can be relational database එකක තියෙන table ටික අපි physically හිතුවොත් ඒ හැම table එකක්ම අනිත් හැම table එකක් එක්කම නූලකින් connect වෙලා නැහැ. But ඒ tables ඔක්කොම somehow connected. Right? අපි database එකේ කෙලවරක තියෙන table එකකට නූලක් ගැට ගහලා උඩට ඉස්සුවොත් tables ඔක්කොම මේ නූලෙන් බැඳිලා එනවා. Because somehow it is connected. Right? Now if you take these three tables, so student table is connected with the borrowing table, as well as the book table is connected with the borrowing table. And book table and the student table does not have a direct connection or a direct reference, right? But they are connected in some way, right? So that is what we call relational database. All right. So they have given many different examples. Let's write it down in a very shorter manner. Okay, so yeah, I want you to hold on. Yeah, just have the heading called relational database and write down these three factors. Let me know when you are done, people. Right, two are done. How about the others? Anyone who is still writing? All right, Benuk. Hurry up. Right. So now, yeah, we don't need to go for these kind of one. So let's, yeah, hold on. It's better we draw this one, people, right? So this will indicate what is a record, what is a field, right? And when you are drawing this, I want you to do these changes. Yeah, have the field names, have the record. Yeah, and here, over here, yeah, it's better you have the word record, right? And put this word row within the brackets, right? And here, do the same. Yeah. Yeah, do these two changes as well, right? Okay, let me know when you are done. Yeah, so Kita, I think we have discussed some of the questions like 2 or 3 weeks back. And what are the lessons that your school has covered now? It's like when it comes to the second term, some school goes with some different lessons, some school goes with their different agendas. So generally, like you got 9 lessons in your book. So second term test is going to be from 6 of those, but those 6 will be determined by the lessons which has done by your school. It can be differ from school to school. Like in our school, we are just completing the first, second, third, and fourth lessons, and the 6th and 7th. That means Word and Excel. So from 1 to 4 and Word and Excel will be covered, is being covered. So we are giving the questions from those lessons. So for third lesson, we are keeping the operating system, PowerPoint, and the database. So you have to go through the lessons which is done by your school. And when it comes to the questions part, most probably, if you're done with Excel, there will be an Excel question. There will be a question from Word as well, since it is the second term test, and from logic gates, definitely. Number system calculations. Those can be considered as the crucial ones. Tesandu, api පොඩ්ඩි දුරක් ආවා පුතා. ඒ කියන්නේ ළමයි just give me a second. මම මෙතන තෙසන්තුට පෙන්නලා දෙන්නම් අපි ලියපු ටික. තෙසන්තු මෙන්න මේ page number 257 වල මේ highlight කරලා තියෙන ටික ලියාගත්තා. Then after we are drawing this particular table with these changes. Okay, one is done. How about others? Anyone who is still writing? Okay, can we move forward then? All right. So moving forward, right. So with that, yeah, the relationship. Yeah, I want you to copy these tables down at home, people. So it will show you how the relationship is happening, right? So before that, hold on. Yeah. Yes, so yeah, I want you to have this heading, putting the heading over here. right? So heading is going to be this: relationship of tables in a relational database. So under that, you can have this sentence, right? Relationship of tables in a relational database. Under that, you can have this sentence, and then keep enough space to draw this diagram, people. Draw these tables, which is in 259, page number 259. That's going to be your homework. Give me a second. Right, Lamai, sorry for that. Okay, so as I told you, this is the heading. This should be written. Under that, this should be drawn. Okay, clear? So I'm moving forward. So here we are going to learn about the primary key. Now, when we are creating or when we are dealing with a relational database, you saw that the tables has the relationship using some particular fields. Now, if you take an example, if you take the same example over here, these tables are related to each other using some common fields. If you think about the first table, which has the student details, and the next table, which has the borrowing details, these two tables are related using the student number, right? And if you think about the borrowing table and the book table, these two tables are related from the book number, right? So are you clear with what I'm saying, people? How the relations are being made? Yes, everyone? Is it clear how the relations are being made? Okay. Now then, like when we are creating the relationships, when we are creating the relationship like this, can we take any common field, or like can we randomly choose a field from a table and use it to have a relationship with another table, right? අපිට එහෙම පුළුවන්ද? කියන්නේ අපිට කැමති column එකක් තෝරලා අරගෙන ඒකයි තව table එකකට ඒ column එක දාලා එහෙම relationship එකක් හදන්න පුළුවන්ද? නැත්නම් ඒකට ක්‍රමයක් තියෙනවද? It has a method. අපිට බෑ randomly field එකක් අරගෙන to create a relationship, right? So to create a relationship, we need something called primary key, right? So primary key is the field or is the column, or it can be a combination of columns, right? Which identify a record uniquely, right? So primary key is the field or combination of fields which identify a record uniquely. Now think about yourself in the school. So to identify yourself in the school uniquely, what are they using? Yes, if you need to be identified uniquely in the school, what is the component that they are using? What kind of a detail that they are using? Very good, Damya. Yes, others? What is the component that they are using, or what's the detail that they are using to identify yourself uniquely in the school? Yes, Denuka, that's right. Yes, Dinelka, it's the admission number, right? So why they are using the admission number? Because it is not repeated, right? Once an admission number is given to you, it's your admission number. No one is going to have the same admission number if it is not a mistake, right? Then using that admission number, you can clearly identify. Can anyone use your name to identify you uniquely? You won't, because your name can be there for someone else, right? If you take the name Supun, there can be many Supuns. If you take Saman, there can be many Samans. If you take like if you take let's take some of your names. If you take Dinelka, there will be many Dinelkas, right? But when it comes to the admission number, it's unique for you. Likewise, we can't take our date of birth to uniquely identify us, because there can be people who have the same birth date, right? We can't use the age. We can't use the address, right? If you and your sister is going to, your brother is going to the same school, there will be two students from the same address, right? So that cannot be. So the field that has the ability of identifying a particular record uniquely is called the primary key. So that is why in the above example in here, they have taken this student number as the primary key. And here in the book number is taken as the primary key. Now, it's true, the title is not being repeated. It seems unique over here. As well as when it comes to the author's names, it feels unique over here. But they are they have the possibility to be repeated at some point, right? But when you have given a unique number or a unique code, it is unique, like your admission number. And as you can see, in the first table, student number, it's just one single column that they use, right? 100 is to identify Manoj Dayaratna, 101 is there to identify Firoza Rafiq. And if you take the books, 4 ones will be identify the basic maths concept, 4 twos will be identify folk songs, 4 threes will be identify drama. But when it comes to the borrowing table, the middle table, can you identify a borrowing just by using the student number? You won't be able to, because here you got 101 as well as here you got 101, right? So that means a particular student will be able to do many borrowings. So in those cases, student number will be repeated. On the same way, we can't take the book number as well. Can you see it? The 3333 book, the book number which contains 3333 is being borrowed by the 100 student, right, on some particular date, and on some other date, the same student has borrowed that. So if you think about the book number alone, it won't give you unique values. So a particular table does not contain a field which has unique value, one field which does not have unique values. So we don't have the ability of choosing one single column as a primary key. So you have to understand this clearly. If a particular column does not have unique values, we can't use that particular column as the primary key. If the entire table has the same nature, or like all the columns inside the table separately does not contain unique values. So we can't take one particular column which is going to be qualified as a primary key. So in such cases, we are going to choose a primary key by combining 2 or more fields. There is no rule that you must have only 2 columns. You can have 2 or more columns to form a particular primary key. Now, in the center table, the middle table, these 2 columns will satisfy the uniqueness. See, 101, 2222. And from all the records, you won't find any record which contains 101, 22, 22 together. Right? But again, there can be a problem. Here, what's happening here? 100, 33, 33. And it is being repeated over here, 100, 33, 33. That means, is it sufficient to have 2 columns? Yes, people, is it sufficient to have 2 columns here as the primary key? Will it do the task of the primary key for the second table? It won't. Why? The uniqueness is breached. So in that case, you can expand this. So how we are going to expand? You can have any guess. I'm going to consider the student number, book number, plus date borrowed. Now, if I come to that point, you can see 100, 33, 33, 39 to 14. is not repeated together in anywhere else. So 100, 33, 33, 39214 is only on this particular record. So if I'm proposing a primary key for this table, my proposal will be take student number, book number, and date borrowed together. When a primary key is defined using more than one particular column, when a primary key is defined using more than one particular column, we call it composite primary key. Have it clearly, we call it composite primary key. Okay, people, is that clear? Right, great, brilliant. Okay, so they have talked about the primary key over here and they have given some examples, right? And as well as they are talking about the composite primary key over here and showing that the year cannot be taken as a primary key. So year and sport is taken together as a primary key, right? So before I come to the concept foreign key, let's write some things about the primary key, right? Okay, so have the heading primary key and have this description. And plus write these two as well. Let me know when you are done, people. Right. Some people are done. Is there anyone still writing? Okay, moving forward. Yeah, it's better you write this particular part and draw this structure. As well as regarding the composite primary key, you better write this. Are we done, people? Okay, one is done. How about others? Okay, anyone who is still writing? All right, so moving forward. Yeah. Yeah, it's better you write this line and draw the structure. And we can go and talk about the foreign key. And add this one as well, people. All right. So moving forward, people, I think everyone is done. So here we are going to talk about the foreign key now. Now, earlier we talked about what is a primary key. Primary key is the key or set of keys which identify a record uniquely inside a table, right? Now, foreign key is here to create the relationship in between tables, right? So primary keys are there in each and every table, but foreign key is the one who is capable of creating a relationship in between two or more tables, right? So basically it creates the relationship in between two tables. Now, who can become a foreign key? When we are going to talk about the foreign key, again, we are going to talk about the primary key. The reason is the one who can become a foreign key is always a primary key, right? The one who can become a foreign key is always a primary key. So does that mean a primary key or like a foreign key is a synonym for the primary key? No. I'll tell you how the things are going to happen. Now look at this table. The student table has the registration number, name, date of birth, date of admission, name of the guardian. And look at this table. Now this has candidate number, maths, science, Sinhala, English, and registration number. Now, when you're considering these two tables, it is about the particular examinations over here. They got some results and they have a candidate number. Now, it's like when you are facing to the O-level, you will be given an admission number, right? That admission number and your admission number in the school are two different things, right? So the O-level admission number can be considered as the candidate number. And that admission number is also a unique one to identify yourself in the entire examination, right? So like if you take the population or the student population who are doing the ordinary levels on that year will be identified by unique admission numbers. And that is regarding the examination. And if you take yourself in the school, you will be identified by another admission number that is unique for your school, right? So to reduce the conflict in between the name admission number, I'll take your admission number as the registration number, which is given in your school. And I'll take the candidate number is the number which is given for the O-level examination. So in case if anyone needs to find out what is the name of the person who got B pass for the mathematics, then the way that you are going to find that particular detail is by referring to the registration number of the particular person and referring that registration number and finding his name. Now, when the registration number is in the student table, it is considered as the primary key. And when we are creating the subject table, we duplicate or we have copied the same registration number, or we have included the same registration number as a normal field over here. It's a normal field, not a primary key in the subject table. Subject table has a primary key called candidate number. I'm bored. I will come soon, so I will be ending soon, right? So here in the subject table, the primary key is candidate number. The student table, primary key is registration number. And you can see the same registration number is repeated, or like it include here as the registration number in the subject table. And it is not a primary key, but it is a primary key of another table. And that describes the definition of the foreign key. So the definition of the foreign key can be defined a primary key of another table, right? So the foreign key is defined as a normal field in a one particular table, which is acting as a primary key of another table. And again, he is the one who is responsible of creating the relationship, right? Because of these two columns, these tables are related to each other. Is that clear? Yes, everyone, is that clear? Great. So remember, who could be a foreign key? A primary key of another table has the ability of being a foreign key, right? Okay, great. Shall we write down? Here we go. So let's have the heading foreign key, and yes, this entire thing, it's better. It describes the foreign key very clearly. Please have that paper. Are we done, people? People, are we done? Okay, is there anyone who's still writing? Okay, so let's move forward. Let me see. What? Take it over here, Susu. You can drink this if you want to. Okay. It's delicious for you. All right, all right. I will have it, Susu. I will have it with me. Okay. Yes, yes. And it's better you have this one down, people. Yeah. Yes. People, I need you to have the room or have the space to draw this particular thing, and it indicates clearly what is primary key and how the foreign key is implemented, right? So yes, please vacant the room or like keep the space to draw this. So this is page number 262, right? So please take it down, and you don't need to write this explanation over here. I think this can be clearly explained or like clearly understand by you, since we know the things, right? So you don't need to write this, but please draw these two tables and have the primary key and foreign key thing. And yeah, and I need you to do one particular change, people. I want you to have an arrow pointing toward this as well, like this. So these are called primary keys, and the foreign key, this shows the relationship, right? So yeah, people, it doesn't matter. Just take the time and draw this quickly. Otherwise, you will mix this up when you are going to draw it again at home, right? You don't need to write the explanation over here, people. So just draw the two tables. Do it now, people. Do it now. Okay, one is done. How about others? Anyone who is still writing? Okay, Denuka. All right. So, yeah, let me clear the annotation and let me see. Do we have anything else to write regarding the foreign key? Hold on. Yeah. Yes. People, please copy this down. Then we can end the session for today, right? So by next week, we are going to continue, and we have a very little theory stuff to talk about regarding the database. Then I'm going to do the practicals, right? So by next week, we will be able to go through the practicals, I guess, right? So please copy this down, and we can end the session, right? So thank you very much, everyone. I'll see you on next week for the very same time, right? So let's go for the database applications, right? Okay, have a very nice weekend, people. Thank you very much.